In this video, you will learn how to factor a quadratic trinomial or a polynomial in second degree with three terms. Specifically, this is the case where the leading coefficient a equals 1. This is also known as the AC method, since the first step is to multiply a and c together, which these are the leading coefficient and the constants. The beauty of this method is that this is a shortcut of the AC method, where in the other case, where a does not equal 1, that involves more steps since you're using factoring by grouping. Let me know if you have any questions in the comments below, and don't forget to subscribe so you don't miss out on future videos. Let's jump right in. How to factor a quadratic or degree 2 polynomial. I do want to stress here that the highest exponent or the degree has to be 2 because many times I've actually seen students perform the quadratic method and it might be a degree 3 or a degree 4 polynomial. So pay attention to the degree. It can only be 2, and in that case, there are two methods where we can factor quadratic polynomials. One where the leading coefficient, or a, is equal to +1, and the other one is where a is not equal to 1. Now, just a reminder, what is a? A is the coefficient of the x squared term. In other words, it's the number attached to the x squared. Could we have labeled it any other variable? Sure, but typically we like to use a. The coefficient of the x term, or the number next to the x term, is b. And the number with no x terms, with no x's attached to it, it's called a constant. We call it c. So this is standard form. You definitely have seen it before, ax squared plus bx plus c. Now, do you have to put, if a polynomial is not in standard form, would it be helpful to rearrange it so that it is in standard form? A lot of people like to do that just so they can identify what a, b, and c is, and that's not mandatory. Okay, so now it's time to do a factoring example where the leading coefficient a is equal to 1. Now, we love these problems because it's not as time consuming and there are not so many steps as the other method, which involves factoring by grouping. So we do have a shortcut method here, and there is a beautiful template. So again, step 1 here is not, it's really optional. So it might help to make sure it's in standard form to help you identify what a, b, and c is. But again, it's not necessary. So just identify what a, b, and c is. Now, if you notice from the a is not equal to 1 method, step 2 and 3 are the exact same thing. So we are still creating a factor tree of a times c, or in this case, it's simply just c, because c times 1 is itself c. And then we have to choose the factors that add up to b. So it's the exact same problem. Oh, excuse me, it's the exact same steps. Okay, so let's do an example. So again, it's important to recognize that this is a degree 2 polynomial, right? Always check that it is, and always check for the leading coefficient. So we have a +1. B is +10, and C is, be very careful, a -24. So we're going to do it using the same 2 steps as we did in the earlier method. We're going to multiply a times c, or people like to simply look at the c term, which is the same thing because -24 times itself would give us back the c, -24. So we're going to do a factor tree of -24, paying attention to the signs. So 1 times -24, or -1 times +24. We can do 3 times -8, or -3 times +8, 2 times -12, or -2 times +12. Okay, so we're going to go through each of them, and then you're supposed to see which ones add up to the b coefficient, which is +10. So it looks like these are the factors, because when we add them together, we do get +10, and this is b. Now, what's beautiful about this method is once you figure out your chosen factors, you're practically done. Right? So here is the template. You're going to enter those chosen factors into a product of each expression saying x plus blank. So you're just going to place the chosen factors into this template. So x plus one of the chosen factors, and you put the other chosen factor in the other parentheses. So If you put a -2, that is correct. Or some people might like to instead say x plus -2 is the exact same thing as saying -2. So we've used that chosen factor, and then we can put a positive 12 in the second expression, and we are done. And again, if you wanted to flip the parentheses, so if you wanted to put x plus 12 times x minus 2, that is completely valid because it is legal to use the commutative property of multiplication. So that would be the same answer. Let's look at another example. So we do have the leading coefficient is +1. Our b is -3, be careful there, and c would be +10. So we're going to do a factor tree of a times c, which is 10. And again, a lot of teachers will just go ahead and look at the numbers, 2 times 5 and 1 times 10, and they'd stop right there. Now just be super careful, because I have seen before students accidentally, they might pick these guys here because maybe in their head, if they do the difference, they might just look at this 3. Maybe if you might not even catch that b is actually negative. So there's a lot of room for error here, just accidentally. If you're nervous or something on a test, people might get tripped up. So another thing to do, right, is also be very mindful of the sign. So a negative times a negative is also a positive, so don't forget to add these. So this is like the full list. So when we go ahead and add everything together, right, when we add those together, let me pick a different color here, how about blue? Right, those add up to +7. 1 plus 10 gives me 11. -2 plus a -5 gives me a -7. And -1 plus a -10 gives me a -11. And you might say, wait a minute, none of these adds up to b. And so this means that this quadratic polynomial is not factorable. So be super careful, because a lot of teachers do like to throw one of these on a quiz or a test, and you just have to make sure you're paying very, very close attention. So if you're doing a factor tree and you're really making sure you add all of the factors, making sure you have all the signs that make sense, you're never going to get this problem wrong. I do just want to do one more example. I always say, again, to use the greatest common factor method to your advantage. So let's say you're asked to factor this problem. You do recognize it's a degree 2 polynomial. Now you notice that a is 2, right? So a is 2, b is -4, and c is -6. And you say, oh, shucks, I'm going to have to do the factoring by grouping method, right? Because a is not equal to 1. So you can go ahead, right, and multiply a times c and do the whole list of steps, split up the middle term, and then factor by grouping. You'll get the exact same answer. But if you always make sure, if you train yourself to always have an eye out for the greatest common factor, it would save you so much time. So you would notice here that you can actually pull out a 2 from every single one of those terms. That's our greatest common factor. So if you do pull out a 2, like the reverse distributive property, 2 times x squared gives me 2x squared, 2 times -2x gives me -4x, and 2 times a -3 gives me a -6. So now what that does is we're going to, instead of factoring this quadratic, we're just going to pay attention to factor this. And then don't forget, extremely importantly, at the very, very end, make sure to put a 2 in front of your product, because otherwise you will be changing the polynomial. So now we're paying attention to this quadratic. So a is +1, b is -2, and c is -3. So not only now you're working with smaller numbers, which is always nice, but now the leading coefficient is +1. So we can do the shortcut method. Okay, so we're going to use find a factor tree of 1 times -3. So we're looking at a factor tree of -3. So the only two options are 1 times -3 and -1 times +3. And we are looking for the factors that add up to -2. So we're looking at 1 and -3 as our chosen factors. Now again, when a is 1, very beautifully, we can enter it into the template, right? So since it's a positive 1, we're going to write x plus 1. And since it's a -3, we can write x minus 3. Now again, when the product here is equal to the x squared minus 2x minus 3, again, we need to make sure we add this 2 here in the product because this is the original polynomial. So do not forget, extremely important. Okay, so we have just saved so much time. So again, make sure you always look out for the greatest common factor. I hope this video helped you learn how to factor a quadratic trinomial where a equals 1. Take a look at my other video where a does not equal 1. That link is in the description below. If you like this video, make sure to subscribe to my channel right now. That way you don't miss out on my future videos like this one. Just click on the subscribe button.